Today we're looking at graphs of linear systems, and really this should say graphs of linear systems word problems. We're going to take a look at two word problems today. In example 1, Sam needs to rent a car for a 1-week trip to Oregon. He is considering two companies. A+ Auto Rental charges $175 plus 10 cents per mile, and Zip Auto Rental charges $220 plus 5 cents per mile. We're going to first define our variables. We're going to let x equal the number of miles driven and y equal the cost, and in this case the cost is in dollars. So we're going to write two equations, one for A+ Auto Rental, which charges $175 plus 10 cents per mile. We're going to write that in slope-intercept form, so it charges 10 cents per mile. We're going to use x for the number of miles, plus $175. Zip Auto Rental charges $220 plus 5 cents per mile, and again we're going to write that in slope-intercept form, 5 cents per mile plus $220. So what we're looking for is under what circumstances is the rental cost for both the companies the same. I want to know when A+ Auto is the same as Zip Auto. Well, I know what my two equations are. My two equations are 0.10x plus 175 and 0.05x plus 220. So that's what I'm going to do. I'm going to set them equal to one another. So A+ Auto, our equation was 1/10 x plus 175, and Zip Auto was 5/100 x plus 220. I'm just going to solve for x. So draw my river, subtract 175 from each side. That's going to cancel. I get 0.10x equals 0.5 plus 45. There's my plus. And then I'm going to subtract 0.5 from each side. I'll go up here, and I will get 0.05x equals 45. And when I divide by 0.05, I get x equals 900. Now it's not 900 chickens, it's 900 miles. So when you drive 900 miles for A+ Rental, and when you drive 900 miles for Zip Auto, your cost will be the same. Well, the second part of that question is, well, what is the cost? So I have to know if x equals 900 miles, how much is the cost for each company going to be? And since we set them equal to each other, they should be the same. So I'm going to take 900 and I'm going to plug it into A+'s equation. So it's 10 cents times 900 miles plus the fee, which is $175, and the cost is $265. So if I do the same thing, if I put 900 into Zip Auto's equation, I get the same number. 220 times 0.05 times 900 will also give me $265. So I want to take a look and see how this looks on the calculator. So I'm going to put both of those equations in the calculator. Y1 is A+ Auto and Y2 is Zip Auto. So again, in Y1 we're putting A+ Auto, and then in Y2 we're putting Zip Auto. And if we go to second in table to look at the x value and the y values for Y1 and Y2, so if we go to second in graph, we can look at the table for A+ Rental, which is the Y1, and then Zip Rental Auto, which is the Y2. So my table only shows up to 6 miles. So at 6 miles, A1 or A+ Auto costs $175.60, and Zip Auto costs $220.30. But I know that they were the same at 900 miles, so now I need to go back and change my window because I don't want to arrow down, I don't want to hit that arrow all the way down to 900 miles. If you hit second in window, this table set's going to come up. I'm going to start my table right here at 900 because I know that's when A plus rental equals zip auto. So when I go to second in graph again, my table is going to start right here at 900. And I can see that when the number of miles, which is X, equals 900, that A plus auto rental is $265 and zip auto rental is $265. So that just confirms what we did in the second question. So the next part says, under what circumstances is renting from zip auto cheaper than renting from A plus? Well, I want to know when what number of miles is going to be cheaper to rent from zip auto. So if I look at anything bigger than $900 or 900 miles, sorry, A plus auto rental is $265.10 and zip auto rental is $265.05. If I look less than 900 miles, A plus rental is $264.90 and zip auto is $264.95. So we can see that anything bigger than 900 miles or more than 900 miles is going to be cheaper to rent a vehicle from zip auto rental. So again, I want to know when zip auto rental is cheaper than renting from A plus, and we figured out from our list on our calculator that when A plus or zip auto, when the miles are bigger than 900, it's cheaper to rent from zip auto rental than it is from A plus rental. Last question, suppose Sam rents a car from A plus and drives it 225 miles. What is the rental cost? So when X is 225 miles, I want to know what is the cost. So we're just going to use A plus's equation. Y equals 175 plus 10 cents times 225 miles, and that gives us a total cost of $197.50. Okay, question 2. Maggie lives 1,250 meters from school. Ming lives 800 meters from school. Both girls leave for school at the same time. Maggie walks at an average speed of 70 meters per minute, and Ming walks an average speed of 40 meters per minute. Maggie's route takes her past Ming's house. A quick diagram up here. Maggie's distance to school is 1,250 miles. She has to go past Ming's house, and Ming's distance from school, is 800 meters, not miles. So we need to write an equation that shows Maggie and Ming's distance from school in T minutes after they leave their homes. So again, we're going to define our variables. We're going to let D equal distance, and T equal time. And in terms of X and Y, the distance is Y and the time is X. So we're going to write an equation for both girls. Maggie's distance, she lives 1,250 meters from school, and we want to know, as her distance, her speed is 70 meters per minute, so that means her distance from school is going to be decreasing by 70 meters per minute. Ming's distance from school is 800 meters, and again, as she walks, her distance to the school decreases, and she's walking at a rate of 40 meters per minute. So the question is, when, if ever, will Maggie catch up to Ming? And what that means is, when are their distances, the distance that Maggie has traveled and the distance that Ming has traveled, when are their distances going to be the same? So we're going to take both their equations, the distance for Maggie, which is 1,250 minus 70t, and the distance for Ming, we want to know when they're going to be the same, which is 800 minus 40t. So we're trying to figure what time, how long will it take for Maggie to catch up to Ming, and we're just going to solve that equation. I'm going to add 70t to each side. That's going to give me 1250 equals 800 plus 30t, subtract 800. They're going to cancel out over here, and what I'm getting left with is 450 equals 30t. Divide each side by 30, and we get 15 equals t. So that means after 15 minutes, Maggie will catch up with Min. Okay, similar question to the other one. How long will Maggie remain behind Ming? So I want to know how long will it takes Maggie 15 minutes to catch up to Ming. So I want to know how long will she remain behind Ming, and clearly it's obvious. Any time that is less than 15 minutes is when Maggie will remain behind Ming. Will remain behind Ming for less than 15 minutes. Okay, last question. At what times is the distance between the two girls less than 20 meters? So less than 20 meters. So this is where I'm going to go back to my calculator. I'm going to use my y1 equation. I'm going to put in Ming's equation. No, I'm sorry, Maggie's equation. And in y2, I'm going to put in Ming's equation, which is 800 minus 40t. So again, in y1 is Maggie's equation, and in y2 is Ming's equation. So when I hit my second in list, or second in graph button, I can see when the time is 15 minutes, they have traveled the same distance, which is when Maggie caught up to Min. So I'm looking for a difference of less than 20 meters. And if I look at 15 minutes is when they're the same, but if I look at 14 minutes, the difference there is 30, and if I look at 16 minutes, the difference there is also 30. So somewhere in between 14 and 15 is 16 is where I'm going to find a difference of less than 20 meters. But I need to change the scale on my calculator because right now, again, my x values are counting by 1. So I went into second and window, and I changed my x scale to 0.5. So if I look at 14.5 minutes, the difference between 235 and 220 is 15 meters. And if I look at 15.5 minutes, the difference between 165 and 180 is also 15 meters. So when the time is 14.5 seconds, sorry, not 14.5 seconds, 14.5 minutes, and also when the time is 15.5 minutes, at this time the distance between Maggie and Ming is 15 meters, and at 15.5 minutes the distance between Maggie and Ming is also 15 meters. And the only thing I did there was I subtracted 235 and 220, and then 165 and 180. And sometimes to get the exact time, you have to go in and change your scale. And again, you do that by going to second and window and changing your x scale. Okay, it's your turn to solve these two system word problems. Number 1, multiple choice. Number 2, free response. And the directions say to use your graphing calculator. You can use your graphing calculator. You can graph it on graph paper if you'd like to, or you can just set the equations equal to one another to find out this one for the point of intersection for number 1. And then for number 2, write your equations, but just give the answer as an ordered pair. So the question is asking, in order to make the best decision, he figures out how many attendees it would take to have the venue cost the same. First answer is the number of attendees, and the second answer is what the cost. And so what the cost is, and you're going to put that in an ordered pair. So the x value is the number of attendees, and the y is the cost.